Hi everybody, I'm going to go through the 2018 electricity paper and I'm going to look at question 3, which is what you had for homework. I've drawn the circuit here and you can see I've got one bulb number 1 in series and then bulbs 2 and 3 in parallel. And I've set up a little table by the side here so that I can keep track of the individual components, okay? The things I know are the supply voltage, which is 12 volts, okay? And part A asks us to find the total resistance of the circuit, and we need to show that it's 10. So the first thing we're going to do is look at the parallel parts. And the formula for that is 1 over parallel is 1 over 4.8 plus 1 over 7. Okay, and so we work that out. 1 over 4.8 plus 1 over 7 is 0.35. 1 over R parallel is 0.3511, and then we need to turn that up the other way. And get 2.847. And then your R total is the 7 ohms of bulb 1 plus the 2.847 of the parallel section, which gives us 9.847 ohms. And when you round that to two significant figures, one significant figure, it becomes 10 ohms. So you've shown that the total resistance is 10. Okay, that's what's required for part A. So we know voltage supply is 12. Now we know that the total resistance is 9.847 ohms. I'm going to use that number because that's more accurate, remember. So we'll move across here for part B. Part B asks us to calculate the voltages across bulb 1 and bulb 2. So before we can do that, we need to find the circuit current. And to do that, we use V equals IR, but we're going to look at that for the whole circuit. So the circuit current is going to be the supply voltage divided by the total resistance. So that is 12 divided by 9.847, and that gives us 1.22 amps. So that's the current that's flowing through bulb 1. So for bulb 1, to get the voltage, the voltage of bulb 1 is going to be the current going through bulb 1 times the resistance of bulb 1. So that is 1.22 times 7, which gives us 8.53 volts. And I'm just going to write that up here so I know what that is. And then the voltage going through 2, well, we need to work out the current going through 2 because the current is, the voltage going through both of those parallel branches will be whatever's left out of the supply voltage of 12. So the voltage going through bulb 2 is going to be the supply voltage minus the voltage used in bulb 1. So that's going to be at 12 minus 8.53, which is going to give us 3.47 volts. And that will be the same for bulbs 2 and 3 because in parallel each branch gets the same. Okay, that's part B done. There are your two answers there. and that is worth merit if you get both of them right, or achieved if you get one of them right. The answer to A was achieved. Now part C. In part C, you are asked about the brightness of bulbs 2 and 3. So for brightness, we need to consider power. And the formula for power is P equals IV. So the first thing we're going to then need to do is work out the current through 2 and through 3. So we've got our resistance and voltage. So the current through bulb 2 is going to be the voltage over the resistance of bulb 2. So the voltage through bulb 2 is 3.47 divided by 4.8, which gives us let me just work that out. 3.47 divided by 4.8, 0.72 amps, and the current through 3 is the voltage over the resistance of that component. So that's 3.47 over 7, and that's 0.5 of an amp. And so the power of bulb 2 is the current, 0.72, times the voltage, which is 2.5 watts, and the power through 3 is 0.5 times 3.47, which is 1.7 watts. Okay, so I've done my calculations, and the reason I like to do the calculations is because now I've got something to write about. Okay, so the first thing we're going to say is the voltage across both bulbs is the same. Okay, then I've done my voltage statement. Now I'm going to do my rip out the answer. So the resistance of bulb 3 is higher than bulb 2. Okay, this means bulb 2 will have a greater current flowing through it. Okay, R, I, and the last one, P. If the voltage is the same, but more current, is flowing, bulb 2 will have a higher power output because P equals IV, with V being the same and I is greater, so P is going to be greater. The result will be bulb 2 will be that bulb 2 is brighter than bulb 1. And if you manage to get all that written down, that will give you excellence. Okay. Now let's have a look at the last part, which is also excellence. And I'm just going to redraw the circuit. Sorry, it's a bit messy. And it's a little bit different this time because what they're doing is they're adding in an ammeter in parallel with the light bulb, which you wouldn't normally do, because what's going to happen, and I'll just draw out this, what's going to happen is the current will come out of there, and instead of flowing through the bulb, okay, this is high R, much higher resistance than the ammeter side. And so what's going to happen is all of the current will come out of the power pack and it will all come down here. So all the current will come down through the ammeter. And so that's called a short circuit. Okay, all the current will flow through the ammeter and will short circuit bulb 1. Now you can pretty much then ignore bulb 1. So what that's going to do is kind of do the equivalent of removing the bulb from the circuit. So going back to our RIP again, the first thing that that's going to do is decrease the total resistance of the circuit. Okay, and because the supply voltage is constant, the circuit current increases. And that's your V equals IR. Voltage is the same, resistance goes down, so current goes up. Okay, so if the circuit current increases and bulb 1 will use no voltage because there's no current going through it. So the voltage across the parallel branches will increase. If bulbs 2 and 3 have more current flowing through them, and more voltage. Remember, voltage is energy, so I'm going to say more voltage dropped across them. The power output will increase. That's your RIP. So they will both be brighter. And that's also for a second excellence. Okay, so I hope that makes sense. Thanks.